the beginning, God created the heavens and the earth. Now, the Bible was not originally written in the English language, as shocking as that sounds. But it was written in the Hebrew language, and in the Hebrew language, the word for God in this first verse of the Bible looks something like this. If you were to spell it in English, it would look something like this, and it's pronounced Elohim. Let me hear you say Elohim. In the beginning, Elohim created the heavens and the earth. Now, the word for create is the word bara. Let me hear you say bara. It's this forceful, energetic word of making things out of nothing. In the beginning, Elohim barad, the heavens and the earth. Now, the earth was formless and void. The Hebrew phrase is tohu vavohu, which gives me great pleasure to say. Some translate it wild and waste. The Spirit of God was hovering over the waters. This Elohim has some sort of spirit. And then God spoke and said, "Let there be light." And there was light. God saw that the light was good and separated the light from the dark. The light was called day, the dark was called night. It was evening and morning the first day. So God speaks some sort of word and makes things. In verse 1, this God is some sort of creator. In verse 2, this God is some sort of spirit. And in verse 3, this God is some sort of word. This God is one, and yet this God is several. God is some sort of multiple persons, some sort of community of creativity. What a strange way to begin a very, very long book. Now, God says, "Let there be an expanse in the sky to separate the waters above from the waters below." And so God makes this expanse and calls it sky, and it separates the waters above from the waters below. And it was evening and it was morning the second day. So in this poem, right away, there's this refrain, and it was evening and morning the first day, and it was evening and morning the second day. Well, we don't say it that way. We say morning, that evening. But in this poem, which is what it is, it's evening, then morning. We'll get to that in a couple hours. Now, God said, "Let the waters be gathered to one place and let dry ground appear." These gathered waters God called seas, and this dry ground God called land. And it was evening and it was morning the third day. And then God said, "Let there be lights in the expanse of the sky to give light to the earth and to serve as signs to mark the days, the years, and the seasons." God made a greater light to govern the day, a lesser light to govern the night, and God also made stars. And God saw that it was good. And it was evening and it was morning, the fourth day. And then God said, "Let the waters fill with teeming creatures and let them reproduce according to their kinds." They'll figure out how. And then let the skies be filled with winged creatures, and then let them reproduce according to their kinds. And it was evening and it was morning the fifth day, birds and fish. And then God said, "Let there be animals, let there be livestock, let there be wild animals, let there be animals that crawl on their bellies, let there be small dogs whose owners dress them in sweaters at Christmas time." And God said, it's a little bit weird, but nevertheless, it's good. And then God said, "Let us make man and women in our image." And so God made people, and God saw that it was very good. And it was evening and it was morning the sixth day. And then God saw all that God had made, and God rested. Now, birds go in the sky and fish go in water. Thank you. It's been great. The sun, moon, and stars, well, they essentially go in space, serve it to give us light and dark. Animals and humans go on land and sea. The things in day 4 fill in day 1, the things in day 5 correspond to day 2, and the things in day 6 relate to day 3. In fact, the dominant work in the first 3 days is God separates, and in the second 3 days, God fills what has previously been separated. So the days are all interconnected. Never mind the fact that the way that we measure an actual day is the movement of the sun, the moon, and the stars. And so the way that we move a day, the planets, doesn't come till day 4, which raises the question, how do you know the first 3 days are actually days? What a fascinating poem. Now, if you begin to look just another layer deeper and ask, well, are there any patterns that might tell us what it's about? Well, this word bara is kind of the driving, it's the engine of the poem. God creates, God creates. The word bara occurs in 3 different points throughout the poem, and at the last time it occurs, it repeats 3 times. It sort of jumped out to the first hearer of this poem. And this God has a 3-in-1-ness. So there is a 3 figures dominantly in the poem, which raises the question, are there any other patterns that we should be looking for? Well, the first verse in the Bible has 7 words. The second verse in the Hebrew language has 14 words, 7 times 2. The word earth occurs 21 times, 7 times 3. The 7th paragraph has 35 words, 7 times 5. The word God appears in this poem 35 times, 7 times 5. And the phrase, "it was so," occurs 7 times. And the phrase, "and God saw," occurs 7 times. There are 7s and patterns of 7s all throughout the poem. It's arranged in patterns. Now, if there's lots of 3s and there's lots of 7s, the question, of course, is, are there any 10s? If you have that kind of time on your hands. The phrase "to make" occurs 10 times. The phrase "according to their kinds" occurs 10 times. The phrase "and God said" occurs 10 times, 3 times in relation to people, 7 times in relation to other creatures. And the phrase "let there be" occurs 10 times, 3 times for things in heavens, 7 times for things on earth. You begin to think the writer had help. So the question remains, what's it about? If you've never read the Bible and you opened it up and you read this first poem, this opening stanza, and you were asked, what's it about? I assume, well, it starts with God, and it starts with God creating. There's all sorts of creating, but then it ends, "and God rested." Now there's this rhythm, there's this cadence, there's this beat to the poem. Evening, morning, and it was evening, morning, second day, evening, morning, third day. It has a certain groove to it, and yet this groove is glaringly absent. Day 7 doesn't have, and it was evening in the morning. Day 7 is just, "and then God rested." And the 7th day just kind of continues on. The rest have a definite ending. The 7th just lingers on and carries forward. I imagine if you were asked, well, what's it about? It must have something to do with God creating and God resting. And then it must have something to do with people and our role in the midst of this creation. It begins with God creating, but it ends very glaringly with God resting. And somewhere in the middle is this vast creation with humans right in the middle of it. And the universe is vast. It's massive. Scientists are generally agreed that our universe has somewhere around 100 billion galaxies. Somebody counted. And the general estimate is that each of those galaxies has somewhere around 100 billion suns. And they believe that each of those suns has at least 100 billion stars. And they're now estimating that our galaxy alone has at least 100 billion black holes, which is why some afternoons you feel slightly depressed. Now, when you get to the bigness of the universe, things get very strange very fast. There's a galaxy called the Andromeda Galaxy, which is racing through our universe at 200,000 miles an hour. Stars do unbelievably strange things. There are stars called neutron stars. They are essentially what's called hyperdense, which means their gravitational pull is so strong that these stars are literally turning in on themselves. When this gravitational pull becomes so strong that it pulls the star in on itself, then its weight, density, mass, and volume takes on all sorts of strange characteristics. Here's an example. A neutron star weighs has a friend named SpongeBob. Unbelievable. The art police would make an arrest for that, just boom. Now, a neutron star weighs several hundred million tons. A neutron star weighs several hundred million tons and fits in a teaspoon. When you deal with the bigness of the universe, things get very strange very fast. Nothing is as strange as light, which comes from suns in the form of particles called photons. And photons travel at the speed of light. Now, yes, the speed of light is incidentally the speed of light. Now, at the speed of light, and the way that light travels in particles called photons, things get even weirder. Here's an example. Let's say you're standing in the street, and you see a car coming at you at 20 miles an hour. You elect not to step onto the curb this way or to step onto the curb this way, but you decide to turn and run as fast as you can away from the car that's coming at you at 20 miles an hour. We don't know why you do things like this. So you turn and you run as fast as you can away from the oncoming car, because when you run, you feel his pleasure. Now, let's say the car is coming at 20 miles an hour and you reach a top speed of 10 miles an hour. Now, when you were standing still, the car was coming at you at 20. If you reach 10 miles an hour and you look back, the car will now be bearing down on you at what speed? 10. Well done. Now, let's draw this just because I think oftentimes the drawings help. Here's you. And interestingly enough, you've grown dreadlocks for the occasion. Now, 10, 20 equals 10. And we all say this because we have what's called a Newtonian understanding of the universe. Isaac Newton, mechanical laws of physics. An object in motion stays in motion unless acted on by an outside. Flashbacks to 9th grade. We were taught that there are these rules that govern how the universe functions. Safe, predictable, plug in the numbers, and you'll get your answer. We were essentially taught what's called a cause and effect understanding of the universe. Certain things work on other things to produce and lead to certain results. Give me A, give me B, I'll give you C. The problem is, light travels at 670 million miles an hour. If you're standing in the street and a particle of light comes at you, and you turn to run the other way, which raises a whole other set of questions. If you're standing still, it comes at you at the speed of light. If you turn and run 1 mile an hour, 10 miles an hour, 100 miles an hour, 1,000,000 miles an hour, and look back, that particle of light will always be bearing down at you at the exact same speed, the speed of light. Well, a man named Albert Einstein got onto this in roughly 1915. He said, wait. The more he discovered about light, he said, hold on, light doesn't follow any of the rules of our Newtonian understanding of the universe. Einstein said, wait. He essentially said the universe is not static. When it comes to light, there is no A plus B. Light just does its own thing. When you get to the bigness of the universe bends and it warps and it distorts, and it doesn't matter how fast you run away from light, it always will be pursuing you at the exact same speed. Well, as you can imagine, this is obviously his general theory of relativity was an absolute revolution in the way people saw the universe, because it was assumed that the universe had these predictable, predetermined ways that it operates. But with light, it simply doesn't follow any of those. The universe and its bigness is just plain weird. They've even found in our galaxy a planet which is racing through our galaxy at 67,000 miles an hour. At the same time it's racing through our galaxy at 67,000 miles an hour, it's also spinning, rotating at 1,000 miles an hour. This planet is called Earth, and this is why you should wear a seatbelt. Now, the Earth has a sun, or maybe we should say our sun has us. The Earth receives 99% of its energy from the sun. The sun converts for us 4 million tons of energy every second, and over an 11-year sun cycle, that energy output varies less than 1/10 of 1%. All of this at a distance of 93 million miles. 92 million miles, no life on planet Earth. 94 million miles, no life on planet Earth. Now, the Earth is unusual from other planets in that the Earth tilts on its axis at 23.5 degrees. Other planets in the solar system? Earth. Now, the question is, why does the Earth tilt? Well, if the Earth did not tilt, it would run the risk of becoming what's called tidally locked, which means one side of the Earth would get stuck facing the sun all the time, while the other side would never see the sun. So the one side of the Earth would get hotter and hotter and hotter until it could not sustain human life, while the other side would get colder and colder and colder until it could not sustain human life. So this 23.5 degree tilt of the Earth's axis is just exactly precise to allow this little blue and green floating ball to sustain human life, which raises the question, why does it tilt? It tilts because 40% of a gravitational pull that comes from the sun pulls it over. The other 60% of that tilt comes from the gravitational pull of a little rock we've come to know as the moon. The moon and this pull is what allows planet Earth to sustain life. No moon, no life, which raises the question, how did we get our moon? Scientists believe that our moon was some sort of meteor or asteroid that was just flying through our galaxy and essentially got stuck in the Earth's gravitational pull, making it the cosmological equivalent of, oh, all right. But I have a dark side. Hydrogen on planet Earth must convert 1/7,000th of its mass to helium continually for the Earth to sustain human life. 0.007, 0.008, no life on planet Earth. 0.006, no life on planet Earth. Our atmosphere is 21% oxygen, 23% oxygen, no life on planet Earth. 19% oxygen, no life on planet Earth. The ocean, our oceans are 3.4% salt. The oceans are 3.4% salt, which is the exact percentage of salt in the human bloodstream. 4% salt in the oceans or our bloodstream, no life on planet Earth. 2% salt in our bloodstream or the oceans, no life on planet Earth. This is, by the way, called the science of fine-tuning. And there are hundreds and hundreds and hundreds of these unbelievably precise numbers that all add up to life on planet Earth. Carbon levels, gravitational force, the density of particular minerals and primal elements that all add up perfectly. The metaphor is simply this. It's as if there are these dials to create and sustain life on planet Earth. It's as if there are hundreds and hundreds and hundreds and hundreds of these dials, and every single one of them has been adjusted just perfectly. And this one goes to 11. And every single one of them adjusted just perfectly. Hundreds of them. It isn't just that there are hundreds and hundreds of them, and somehow, someone has adjusted them just perfectly. It's the haunting truth that if just one of them were even slightly turned in any direction, it would render the accuracy of all of the hundreds of others irrelevant. It isn't just that there are hundreds and hundreds and hundreds of these dials. It's as if you just messed with one of them. It wouldn't matter about the precise accuracy of every single other one. What a strange, mysterious little floating blue and green ball we call home. Now, the general estimate is that our universe is 10 to the 27th power meters across. Once again, somebody measured. And the general estimate is that the smallest thing in our universe is a subatomic particle, 10 to the negative 26th power. Now, if you were to take an average of all human beings' heights, if you were to look on planet Earth, what's the average height of all human beings? And so you were to take babies, toddlers, preschool kids, hobbits, adults, you would end up average height of all human beings somewhere around 1 meter, making human beings the middle in size in the universe. And you're fascinating. How many of you can see me? Excellent. Encouraging, to say the least. Yeah, you have this visual cortex in your brain connected ultimately to the retina in your eye. 110 million cones, 7 million rods, over 1 million nerve fibers, all working in harmony so that you can see things. You have over several 100 billion brain cells, neural connections somewhere in the trillions. Every second your brain doing roughly 1 trillion computations, and no one of those brain cells are the same. In any given 1 or 2 second period, your body has just produced 2 to 10 million brand new red blood cells. You have 100 million white blood cells being stored right now in your bone marrow alone, which raises the question, if your body is producing new red cells and white cells to make you, and producing these cells at the rate of hundreds of millions every couple of seconds, how does your body know to make more and more and more of you and not somebody else? Every single one of those cells, hundreds and hundreds of millions of cells, has roughly 6 feet of DNA coiled inside of it. It's like a map. It's a code that tells your body who you are and how to make more of you. If those DNA strands were stretched out into their 6-foot length, and then all of them in your body were put end to end, it would be 80 billion miles of instruction. It would go from the earth to the sun and back 400 times. Your body, down to the 100th, billionth, millionth of a cell, is hardwired to be you and no one else. But those cells are actually made up of a smaller component called an atom. Now, if you wanted to see an atom with your naked eye, you would need to be 1 billionth of an inch tall. And you'd have an incredibly high voice. The earth is to an orange as an orange is to an atom. If we were to count the number of atoms in 1 drop of water, if we were to count the number of atoms in 1 drop of water, it would take every single person on planet Earth counting